When NASA's James Webb Space Telescope blasted off last year, it felt like our world grew a little more hopeful. This wasn't merely a telescope. Webb filled us with wonder, built to unveil a laundry list of the universe's greatest, most mind-bending secrets. It's made to elucidate black holes, confirm we have the Big Bang's story correct, and if they're out there, even find the first signs of alien life. Perhaps the biggest mystery of all is whether there's someone, or something, alive out there in the cosmos. Or if we're utterly alone. Tending to that question, scientists published a paper Monday in the Proceedings of the National Academy of Sciences to explain what, precisely, Webb should be looking for in pursuit of alien life. The short answer is methane, a molecule with 4 hydrogens and a carbon. But if we really want to refine our extraterrestrial hunting handbook, there's a whole lot more to the story. Otherwise, there are 2 things that could go wrong. You could misinterpret something as a biosignature and get a false positive, or you could overlook something that's a real biosignature, Joshua Christensen-Totten, an astrophysicist at the University of California, Santa Cruz and co-author of the study, said in a statement. We wanted to develop a framework to help avoid both of those potential errors with methane. Okay, backing up. Why would we want Webb to search for methane on exoplanets and not, I don't know, maybe oxygen? Well, it's not that simple. The way Webb will find biosignatures, aka signs of life, is by capturing light absorption wavelengths. Basically, different molecules, or elements, absorb different wavelengths, and atmospheric oxygen's absorption properties are pretty difficult to pick up. Oxygen is often talked about as one of the best biosignatures, but it's probably going to be hard to detect with JWST, Maggie Thompson, who's also an astrophysicist at UC Santa Cruz and lead author of the new study, said in a statement. The meaning of methane. In essence, oxygen could be lurking on an exoplanet, saying hey, there's life over here, and easily be missed. But methane isn't too hard to pick up through the absorption mechanism. Plus, methane is pretty vital to life on our planet, so it could also be a good indicator of life. If you detect a lot of methane on a rocky planet, you typically need a massive source to explain that, Christensen-Totten said. We know biological activity creates large amounts of methane on Earth and probably did on the early Earth as well, because making methane is a fairly easy thing to do metabolically. In other words, biological processes on Earth, including those of the human body, release methane often and easily. Reverse engineer that, and finding methane somewhere on a rocky planet in the universe means a life form, maybe even like us, could have made it. But remember, the team's goal is to remove any doubts, or false positives, while Webb scans for such life forms. One molecule is not going to give you the answer, you have to take into account the planet's full context, Thompson said. Methane is one piece of the puzzle, but to determine if there is life on a planet, you have to consider its geochemistry, how it's interacting with its star and the many processes that can affect a planet's atmosphere on geologic timescales. Although we know Earth-based life definitely produces methane, some non-living things make the molecule, too. Volcanoes, ocean ridges, hydrothermal vents and even asteroid impacts, the researchers say, could make a bunch of methane and push it up into the atmosphere. We have to make sure that if Webb finds methane on a rocky planet in the habitable zone, which is the region in every star system most likely to host life, it's not just finding non-biological methane. So, after analyzing what might set non-biological methane apart from biological methane, the researchers came up with a solid rule of thumb for when Webb finally detects the telling molecule on a rocky planet, orbiting a sun-like star and in the habitable zone. They say that if the planet's atmosphere has a lot of carbon dioxide in addition to the methane and has much more methane than carbon monoxide, and if the orb doesn't seem to have an extremely water-rich composition, we might be in the clear to rule out false positives. If any or all of these things don't ring true, it could have come from a non-biological source, like some sort of volcano. In the future, Creason Totten believes, more research with this line of thinking must be done if we're to achieve the seemingly impossible feat of finding life beyond our planet. This study is focused on the most obvious false positives for methane as a biosignature, he said. The atmospheres of rocky exoplanets are probably going to surprise us, and we will need to be cautious in our interpretations.